Students, so in my this new video I'll be discussing about pressure in fluids and Archimedes' principle related with pressure in fluids. So when we say pressure in fluids, in the earlier video I have discussed about pressure in solids, and we have seen that when we place any object, suppose there is the object, we are placing it on a surface, it will exert a certain amount of pressure, which is due to its thrust or force or weight whatsoever. Similarly, since fluids have mass, they are having weight, so the fluids also exert pressure. Now this is an experiment which you have got in your lower classes, that in order to show that pressure in fluids increases with depth. So what we do here, we take a container, or you can take a bottle also, plastic bottle, and make 3 holes at 3 different depth. Okay, and you fill that container with water. What you'll find, as soon as you fill it with water and you open these holes, if it can be opened, if they are open, water will come out directly. You'll find that the water from the lowest hole falls to the farthest distance, thereby showing that with increase in depth, the pressure in case of fluid increases, and the water from the topmost hole will fall nearest to the container, and thereby showing that lesser is the depth, lesser is the pressure in fluids. So whenever we immerse any object inside a fluid, suppose there is an object, a rectangular box, it is immersed in a fluid. So there are 2 forces which will be acting on these boxes. One force will be in the downward direction, which is the weight of the box, which arises due to the gravitational force of attraction, and second one will be the upthrust or the upward force provided by the fluid which is present below this object. So they will tend to push the body in the upward direction, and that is called the upthrust. Okay, so this upthrust we can very easily experience. You take a bucket of water, and in that bucket of water, many of you must have done this many a times inside your washroom, that in a bucket of water, suppose you take a bucket filled with water, and here you try to put in a mug. Okay, a mug, you try to put it in, you'll find that something is pushing the mug in the upward direction, and that is the upthrust. Similarly, like when we move into a swimming pool, our body tends to get pushed upwards, and that is the upthrust or the upward force of the body. Now, depending on the relative values of the weight and the upthrust, it is determined whether a body will float or it will sink when immersed in a fluid. So so these are the conditions of flotation. So in the first case, the body sinks. Now when the body will sink, when the weight of the body will be greater than the upthrust. Next, when the weight is less than upthrust, that means upthrust is more, then the body will float on the fluid. And if in the third condition, if the weight is equal to the upthrust, then what is going to happen? No doubt the body will float, but the body will float remaining submerged. Means wherever you put it inside the fluid, it will tend to stay there. So these are the 3 conditions of flotation. Next, we are going to move over to Archimedes' principle. Okay, so when we are talking about Archimedes' principle, first we'll look into the statement, then we will find out that how we can actually find out the amount of upthrust experienced by a body which is put into a fluid. Now all of you know the classical story of Archimedes, that Archimedes was a known scientist of his time, and like his king, he gave the goldsmith to make a crown of pure gold. And when the crown was returned, no doubt the crown was very beautiful, but the king had some doubt whether the crown was actually made of pure gold or not. Then what happened? He called on Archimedes and he told him that you have to find out without breaking the crown. Without breaking the crown, you have to find out whether the crown is made of pure gold or not. And he thought for many days, he couldn't find out a way. He was tensed, and one day he entered into the bathtub. And as soon as he entered into the bathtub, some amount of water spilled out or flowed out of the bathtub. And all of a sudden, it's like the bulb glowing. Okay, you have seen animation, bulb glowing when someone gets the idea. So suddenly it came to him that how he can find out or actually calculate or find out whether the crown is made of pure gold or not. And in that condition he ran all the way to the king, shouting all the way, Eureka, Eureka. So that's a very, very classical story of Archimedes. So Archimedes' principle, it states that when any body is partially or completely immersed in a fluid, whether you are putting it completely inside the fluid or you are partially immersing it, the body will experience an upward force. Okay, so the body will experience an upthrust, and that upthrust will be equal to what? To the weight of the displaced fluid. So as soon as we suppose there's a mug filled with water, as soon as you put in a ball, suppose you have put a ball, some amount of water will flow out of the mug. So if somehow you can calculate, suppose you are collecting the water here, or whatever fluid it is, and you calculate the weight of this water or the fluid, so that weight will be equal to the upthrust experienced by the body, because upthrust is what? Upward force, and weight is also force. So this weight will be equal to the upthrust. So how we can actually find out that upthrust? There are different ways, there are different practical ways of doing that. First way is using a overflow can. So a overflow can is a device which has an inverted spout. Spout, you know, the outlet. Suppose in a kettle we have a in a typical kettle we have this spout. So this is called the spout, the outlet. So this outlet or the spout, it is inverted in the downward direction, and below the spout what we have done, we have placed a beaker which is placed over a weighing machine or a weighing jar. Now what happens? First we'll fill water up to the brim. Brim means the portion beyond which the water will flow out. So up to here we'll fill up water. Now we will put in the object into the water. As soon as we put it into the water, some amount of water will flow out. Okay, and that weight we will get in the weighing machine. So that weight will be equal to the upthrust experienced by the object. So there's a direct way of finding that out. There is another more easier way, because for this method you will need an overflow can, you'll need a beaker, a weighing machine. All these things are difficult to get. So another easy way is just get hold of a spring balance. Okay, so what we will do is that we will calculate the weight of the body in air. Okay, let's say the weight of the body in air is suppose 50 Newton, because from now onwards, since you have already got the difference of mass and weight in class 9, whenever we say weight, it's better we take the proper unit Newton and not say it as kg. So suppose the weight of the body is 50 Newton when we are weighing it in air. Now as soon as we put this object into the water, what will happen? The body will be pushed up. It will be pushed in the upward direction, because the upthrust is acting opposite to the weight. So the upthrust will push the body. So this reading, the arrow here will go up. Okay, so let's say originally the arrow was here, so it will be pushed up. Pushed up by whom? Pushed up by the upthrust. So suppose now you are reading the weight in fluid, which is written as WF, and WA is the weight in air. Suppose now the weight in fluid is suppose 40 Newton. Okay, so how much has the weight decreased? The weight has decreased by 100 Newton. So who has actually decreased this weight? This weight has been decreased by the upthrust. So the upthrust is equal to loss of weight of the object when immersed in fluid, which is can be written as weight of the object in air minus the weight of the object in fluid. So in a formula form we can put it, upthrust is equal to weight of the object in air minus weight of the object in fluid. So there is a very easy way of actually finding out upthrust. There's a third way out. In this third process, we'll use, for this we have to know a certain value. What is that? I'll tell you. So upthrust we know is weight of the displaced fluid. Okay, so weight of displaced fluid, weight we know, weight is nothing but mass into acceleration due to gravity. So it will be the mass of the displaced fluid into acceleration due to gravity. This we know, it is approximately specifically 9.8, we can approximate it to 10 meter per second square. So that is the value of G throughout the earth. So G will remain G. Now instead of M, now how do we get the mass? We are not, because what we are doing here, we have taken just the you can say there's a measuring cylinder, and measuring cylinder, they are graduated. Graduated means they will have markings here. So what we do, first I'll tell you what we are doing here, then I will tell you how to calculate it. So suppose we take the water up to this level. So this will be the initial volume. So let me measure the initial volume, VI. So let's say the initial volume was 20 ml. Now what I do, I insert the object into the fluid. I immerse the object into the fluid. Once I insert the object in the fluid, what will happen? The volume will increase. Okay, let's say now the volume here, so the final volume VF, suppose it has become 30 ml now. Okay, so what is the increase in the volume? 30 minus 20, that is your 10 ml. So actually 10 ml, now this much of fluid is actually the volume of the object. Now why it is the volume of the object? Suppose in a room it is filled with people, there's no space to enter, and you forcibly enter one person. So how many person will move out from the other end? One person has to move out. So same is the logic here. So same is the logic that when we are inserting the object here, the same volume means the space occupied. How much space is occupied by the ball or the object, that much of fluid will increase here. So the increase will be equal to the volume of the object. Now generally solid object we don't measure in milliliter, we measure in cc or meter cube. So one thing we should know, that 1 cc is equal to 1 cubic centimeter. 1 cubic centimeter means what? A cube whose all the dimension, your length, breadth and height, all the three dimension is 1 centimeter each. So what will be the volume? 1 into 1 into 1. So it is 1 centimeter cube. So it is written as cc. So 1 cc is equal to 1 ml. So 10 ml can be written as 10 cc. So it is very easily convertible between fluid volume and solid volume. It is very easily convertible. So we have got the mass of the displaced fluid. So that is actually not required. We just need the mass of the displaced fluid because we are calculating the weight of the displaced fluid. So weight of the displaced fluid, m into g. G we know it will remain same. Now how do we calculate mass? Now there is a formula for density. You have got before, density is equal to mass by volume. So from this formula, if you want to find out mass, we'll take the volume here. So it will become density into volume. Okay. Now water density is a known value. If you don't know also, you can Google search, is very easy, 1 gram per cc or 1000 kg per meter cube. So if you are using water here, so density is known to us. So G is known, 9.8 or 10 meter per second square. D is known to us as 1000 kg per meter cube or 1 gram per cc, whichever unit you are doing in. And the only thing that we have to get from this experiment, or the value that needs to be taken from the experiment, that is your volume. And how we get volume? Simply minus the final reading minus the initial reading, we get the volume of the displaced water. So V final minus V initial. So by this way also we can calculate the upthrust according to the Archimedes principle. So there are so many applications. I have just cited few here. So in densiometers and lactometers, suppose lactometer is used. It is a device. It comes in varied shape, but it has a bulb below, and with the help of this bulb there will be graduations here. So you can dip this bulb in milk and it will show up to a certain reading. So if you get your standard reading, that means your milk is pure. If you are adding water, then what will happen? The milk will become light. Its density will become less. So what will happen? The densiometer or the lactometer will further sink. When it will sink, the reading will show lesser. So then you can know that your milk is contaminated. Now what do some of the milkman they do is that, in order, they know that the milk will become light, its density will decrease and they will get caught. So in order to maintain the density, they add starch or milk powder. So if they are adding starch, you can very easily test it by adding few drops of iodine. These are chemical tests to test adulteration. So lactometer, densiometer, submarines. What happens in submarines? Most of you know because you all are tech savvy nowadays. So you all like these machines and all. So suppose there's a submarine. Okay, and inside submarine there are some tanks, and these tanks are called the ballast tanks. Okay, these are called the ballast tanks. So suppose the submarine has to sink. So what do the submarine? There are engines which will allow the ballast tank to get filled with water. The moment it gets filled with water, it will become heavy and it will sink. When it has to resurface, they will switch on the pump again. The water will be pumped out, and the submarine will become light, and it will start floating. So in modern day ships also, now the problem of ships is, now when they are moving in your sea, then there is no issues, there are no issues. But suppose the ship from the sea, it tends to enter into a river. Now river, you know, it doesn't have salt, so the density of seawater will be more than that of river water. River water has less density. So as soon as the ship will enter into the river, it will sink because the upthrust will be less, because we have seen upthrust is dependent on density. So more is the density, more thick is the, because you know, you have heard about the fact that people cannot get drowned in Dead Sea because Dead Sea is extremely salty, so its density is very high, so people simply floats in that water. So same thing will happen here. Since there are no salt, there is no salt in river water, so density is less. Density is less means upthrust will less, so the ship will sink deeper into the water, so it might get stuck. So what do they do? They have some weight balancers. So before entering the river, those weight balancers, or it can be sandbags, those are removed from the ship so that the ship becomes lighter and it doesn't sink deeper. Again, while going from the river to the sea, what will happen? The density will be more, so the ship will be pushed upward more. If it is pushed too much high, then its center of your gravity will get disbalanced and it will topple over. Okay, so what happens? Those weight balancers are again put into the ship, or there are similar ballast tank, those are again filled with water so that the ship sinks a bit and its center of gravity is maintained at a proper level. So all these are different applications of your Archimedes principle. So I hope it's clear to you. If you like my video, do share and subscribe to my channel. I'll be coming up with more videos related with your courses. Thank you.